Hello everyone, welcome to the today's lecture on fault models in VLSI design and testing. In this session, we covered the topic about fault model, which includes functional level fault model, structural level fault model, stack and fault, which includes also single stack and fault and multiple stack and fault. So let's begin. As we know, VLSI technology has revolutionized the semiconductor industry by enabling the development of complex, high-performance ICs that powers our smartphone and advanced computing system and other handheld device like smartwatch. With this complexity comes the challenge of ensuring that these circuits are free from defects. Okay, so this is where fault models comes into the play. So if we define a fault model are a cornerstone or important testing feature of VLSI design and testing. They provide a structural and functional approach to identifying and addressing potential defects in ICs. Okay, so fault model ensuring that these digital circuits are reliable, functional and meet their performance requirement. So we can say fault models play a crucial role in overall quality assurance process of semiconductor manufacturing by guiding the development of test patterns and improving fault coverage. So understanding of fault models are not just about the identifying the defects, it's about the ensuring that our technological advancement continue to meet the higher standard of quality and reliability. So next question are hitting our mind that what is the significance of fault model in VLSI. So significance of fault model in VLSI includes guiding test development and improving reliability and quality and ensuring performance and reducing test complexity. Okay, so guiding test development means basically fault model are used to generate test patterns that specifically target the types of fault likely to occur in the circuit. Okay, so these patterns are designed such that to simulate the circuit in ways that will expose fault if they exist. It's okay. Then basically coverage matrices means fault models help in evaluating the effectiveness of test patterns by providing metrics like fault coverage, which basically indicates the percentage of possible faults detected by the test. Okay. So by simulating testing for potential fault early in the design process, engineers can detect and correct issues before the ICs goes into the production. This improves the overall reliability and quality of the final product. So the second point is improving reliability and quality. So these kind of fault models is also used for manufacturing yields. So manufacturing yields, if we say manufacturing yields, it means identifying and eliminating faults during the design phase. Okay, so during the design phase by increase the yield of functional IC from a production batch. This will reduce the cost and wastage, and its fault model also ensures the performance of integrated chip with the help of timing verification and functional integrity. So fault models like transition and path delay faults are critical for ensuring that the circuit meets its timing specification, and this is basically particularly important for high speed and performance sensitive applications. So if we say functional integrity, then models such as the stuck at and bridging faults help ensure that the circuit performs its intended function correctly without any kind of logical error which are going to happen sometimes in the digital circuits. So it will also fault model is also reduce the test complexity by simplifying the complex task of testing by characterizing faults into types that can be systematically addressed. This makes it easier to develop comprehensive and efficient testing strategies. Okay, and many automated test patterns, ATPG, we can say, tools basically rely on fault model to create effective test patterns, reducing need for manual intervention and speeding up the testing process. So the fault is basically a manifestation of manufacturing defects in an IC. So during fabrication, the MOS devices could be fabricated incorrectly, or the interconnects wire could have open circuit and short fault. So all these defects lead to malfunctioning of an IC. So the fault models are used to identify different types of faults. Okay, so there are many kind of fault models stuck at such that stuck at fault, bridging fault model, open short circuit fault model. But if we divide in the category of fault model, we basically divide two level fault model. The first one is functional level fault model. Functional level fault model are the models based on the function of particular block. Okay, so this model is basically a circuit is specified at RTL level. That means netlist of register, adder, or subtractor, multiplexer. So it is basically a function specific, and we don't need to take care of gate level model. So for better understanding, let's take example of mux. Here we consider a 4 cross 1 mux. This mux having 4 input A, B, C, D and 2 select line S1 and S2. So there are basically total of 6 input lines. And if, as we know, the basic function of mux, that is if S1 and S2 is 0, 0, then input A will be propagated to output Q. If S1, S2 is 1, 0, then input C will be propagated to output Q. If S1, S2 is 1, 1, then input T is applied, will propagate to output Q. And this is 0, 1, then input B will be propagated to output. Okay, so the idea behind this functional level fault model is that whatever input is applied to A, suppose there is a fault line A, so whatever input is applied to A, either it is 0 or 1, it will be reflected at the output. So the idea behind it is whatever input to A, that is 0 or 1, then reverse logic is applied to the other inputs. Okay, so if we applied to A is logic 1 or logic 0, the reverse logic, if we applied to A is logic 0, then we have to apply it to logic 1 to the other input B, C and D. Okay, so so that if any fault is here, then it will be detected easily, because the exclusive OR condition exists in between faulty circuits and fault free circuits. Okay,